Discordo. Hey DJ, hi learner. And streaming is so hard. It's not as bad as it could be, honestly. I think after a while I'll get used to it. I got used to it. It definitely helps to have multiple monitors. I don't think I would be able to do a stream off one monitor. I think it would just not be possible. You should set up overlays. Like, designing overlays is actually so much fun. Alright. Hello. A lot of the stuff requires OBS Prime. I don't use OBS Prime. I just have like the standard OBS. I don't even have Streamlabs OBS. It's just, yeah, this is just normal OBS. I don't know if I'm streaming enough to be worth it. I don't know. I didn't know. So before I first stream, I spent a lot of time setting up overlays. Despite not being sure I would stream more than once. I was just like, if I'm gonna do this, I want to do it right. And then I kept streaming, so it paid off, I guess. I probably wouldn't have paid off if I only streamed once. The first stream went so badly. Uh-huh. Really? Whatever. Category is still Celeste? Oh, seriously? I thought I fixed it. Oh. Dang it. Now the whole stream is going to be marked as a Celeste stream. Oh well. 2020 Putnam B6? I actually haven't looked at it. Yeah, I keep decreasing the problem cost. Maybe that's a move in the wrong direction. Alright, well, let's see what's up. Oh my god, 2011 C7. Usimo... No, if it's a Usimo problem from after 2000, I've definitely done it. I'm probably spoiled on a little, at least a little on 2011 C7. I never worked out the details, but man, I just said any Usimo problem after 2000. I've probably done 2001 U6. That's Usimo, right? Like literally, if you check my website, you can see write-ups for every Usimo from 2000 to present. Okay, so 2006 is, which one is that? I apparently haven't done it yet. Okay. Oh, okay. Oh, good luck on Brazil, MO. Are we doing FTW? Probably not unless people really want to. Honestly, I don't do the FTW now because it was just kind of a way to like blow the first half hour of the stream. And I decided it was probably more productive to spend it doing math. Where was I? ISL. Oh. 19. ISL 2000. N6. Wow, what a problem. Okay. Hmm. 2002 C6. Shout out to DJ Mathman for writing such Pog Amy problems from Kevadula. 2002 C6. No one gives me easy problems anymore. I feel like I remember someone telling me that 2002 C6 is not a good problem, but I might be misremembering, so I'll put it on. Alright, let me get the stream started. Episode 58 of this circus. Okay, so those are the two shortlist problems, and then Usman 1997 4 again. What about clipping? Oh, also, there's one thing I want to say, which is that up until now, I've been doing the write-ups offline. Like, once I solve a problem, I just kind of end the video. I think I'm going to start doing the problems, like, write-ups during the stream as well, because otherwise they kind of build up and I never get around to them. So, we would like to start writing up the problems properly. During the stream. What is this? FEOO. He types very much, but it appears so less. Oh, C6. Sorry. We'll see. Yes, this is C6, right? Yeah, C6. Okay, so... Okay, got the bottom for 2020 Putnam B6. Okay. Oh lord, this problem. I don't know if I'm gonna be able to solve this problem. I remember hearing about it though. Yeah, I think this is probably... Is it very easy for you to compile a list of... I probably could at some point, I just haven't gotten around to it yet. Part of the thing is, I guess I think there's some problems that I have when our IPMO problem is being released. Yeah, good question. Okay. Miklos Schweitzer 2000. I probably won't put up the 11C7 because I'm at least spoiled on the answer to 2011C7. Miklos Schweitzer 2008. God, Miklos Schweitzer is so hard. Oh, that one looks like it might be doable. C5 is... Yeah, that one is on a notice unit. I found that one. Okay, I'll type up the problem if it wins the... So many problem requests that someday every problem is going to get at most 1 vote. Yeah, I should start cutting it off at something. Right now there's only 8 that are in contention though, which is a number we've dealt with before. Okay, well now it's 9. I mean, in some sense, like, I want people who are new to the stream to not have to wait too long before they can propose, because it's nice to get different faces around here. So maybe those goals are intention. I think really what I should do is limit it to like the first few people. Just like limit the number of redemptions per stream to like a finite number at some point. Where is this problem from? Canada 2021 4. Okay, I need to shrink everything. The font size is so small. Jeez. Okay, we'll split into left and right, okay? So that we don't have like a 9-way vote. No, we're not doing USMA 2021-3. Oh. I feel like the B6 will just be me like flailing my arms around. Well, okay, people really want to see the B6. It's not impossible. Well, so here's the thing, like, I'm old. I'm not anywhere as good as actually I don't know. I don't think I was ever super good either. But I don't know. I don't know. Maybe it'll work. I guess it just doesn't feel like the kind of problem I would solve or something when I look at it. Alright, well, there's only 2 things that got more than 0 votes. They are 2006 and Putnam 2020 B6. That's fine. Alright, and then... So, Putnam 1986 A6. Schweitzer. Okay. I'll make the font size a little bigger on the right, because there's extra space. You used the word Canadian. This one's more tied. We're at basics, alright. Okay, so problems that we're definitely not getting to today. We're not getting to 2002 C6. Or the clip. Or the FEOL. Let's say no votes. Okay. So I'll refund those now so I can keep track of this. Should I do the Geo first? Start with Geo, okay. Yeah, I feel like I am more confident in my ability to solve a Geo problem on stream than other subjects. So this way we'll get at least one problem solved today. Oh, I was talking about versus like 2000 or versus the Putnam problem. Alright. Unfortunately, this requires me to transcribe the problem from this PDF. Oh, what the heck? There is a computation at the end. Okay, so this is CHMMC 2021-6. Okay, alright, let's transcribe the problem. Oh. Okay. So okay, so there's a mixed linear in circle, and then there's E and F be the points at which the B and C X BX circle. Or tangent to AC and AB to a common point N on the circumcircle of AF. Prove that. Do I have to do part B too? Can't spell. I should use autocomplete more. Suppose that PD over BC equals 2 over 7th. Find with proof the value of cosine. What if I only care about getting 7 points? Okay, I finished typing the problem. See, so for people who think my words per minute is fast, that's demonstration. It's not actually that fast. The thing that I think I'm good at is using the Vim, where if I make a mistake, I don't have to use a mouse to go and fix it. At Twitch. So I'm not pinging. I don't ping at Twitch on in the Otis server. I do ping at live in the V-Enhanced server. So if you're curious, if you want to get pinged when the stream starts, you can subscribe to that rule. But also, like, the stream starts at the same time every week, so I don't know. Like, it's not. It's just at 8 p.m. Eastern. Okay. We need GeoGebra, right? So. It's about 130 sounds right if I'm. I think I've gotten slower. Like, I make a lot of mistakes now. Anyways, that's important. Okay, let's do this. Yeah, I just make a lot of typos, which, at least for like LaTeX, when I'm typing in an editor, I have like Control N. So if I've typed a word before, I don't need to type it a second time. 9, 10, 13, yes. Mega snipe. Okay, welcome back everyone. So today we have a mixed to linear geometry problem from CHMMC that also has a short answer component, much to my annoyance. But let's do the geo part first. So you have a triangle A, B, and C. And let's draw on all the triangle centers. So O is going to be the circumcenter. We'll draw the circumcircle now. And let's see, I is the incenter. So then there's a mixed linear incircle, which is really annoying to draw. What do I call them? Let's call them X and Y. So perpendicular line, I, line AI, that's that line. Well, let's call it X and Y because you enough are taken. Wait, why did X not get defined? Oh. There. Okay, and then Y is interside line XI against the other side, so we're going to find the arc midpoint. And N, well, we'll call L the reflection here. And the mixed linear touch point, for some reason they called it P. Literally should call it T, but whatever. So then P is the mixed linear touch point. Intersect perpendicular line from M to line Li. With line Li. Okay, and then omega A is circle X, Y, P. So that's the mixed linear in circle. There you go. Next, I hate these point names, whatever. So will the U be the intersection? Well, U is the intersection of line AB and a perpendicular line from I to line C. So V is reflect U A. Ah! No. Okay. So those are where the incircle touches. Let's draw the incircle actually. And then E is A plus B minus U. F is A plus C minus B. And then crap. They're flipped. No! Okay, rename. Oh shoot, everything's flipped. Oh, here. Okay, we're gonna do the following. B C1. Okay. Much better. Okay, and they introduced the knockout point. Okay, so actually B and CF. And it's supposed to lie on AEF. Okay, so knockout point is intersection. Just make a swap command. Okay, so what did you do? Let me hide some stuff for now, and wait, put it back later. So here's the mixed linear in circle. I'll color these guys blue so they're easier to see. And then you have the knockout point, and you have a hypothesis that the knockout point lies on the circumcircle at AEF. And you want, what is D? D is, jeez, there's so many points. How do you construct X circle? I didn't construct any X circles. I just constructed the foot of the in-touch and then reflected it. Honestly, blue is bad. Honestly, if I was trying to construct an X circle, I'd probably construct the arc midpoint and then reflect the in-center over the arc midpoint. But unfortunately, that's not needed. So I want the circumcircle. Oh, what the heck is PDO? What is this? Okay, well, the knockout point. Does it pass through I if the condition is true? Looks like they're all concyclic. Why is L defined again? Oh, I defined L because I would use it to construct the mixed linear in circle. But it looks like when AFE... So AFE always passes through L. This is actually a lemma from spiral similarity. So AFE contains L. If you want a reference for this lemma, look at IMO 2013 problem 3. Yeah, so... Okay, I'll say what the proof is, which is that there is a spiral similarity at the intersection point of the light blue circle and the red circle, which maps BF to CE. But because BF is equal to CE, that spiral similarity must actually be a rotation, which means that L should be the upper arc midpoint. And that's how the proof of that goes. Okay, so now if the in-center also lies on there, well, actually, this is all just saying that BF equals IM equals CE, right? Like this spiral similarity at L, not only does it map FB to EC, but it also allegedly should map IM. Okay, so N is on there. Huh. Wow, that's a lot of equivalents. Like, it's equivalent to BF parallel to CM, really? Or is CF parallel to BM and BE parallel to CM? Wait, this is really strange. Okay. What does it mean for N to lie on that circle? No, it doesn't. So the problem hypothesis is that n lies on AEF, and the diagram suggesting that if that is true, then the in-center also lies on there, which would be huge if it was the case. And yeah, it looks like that's true. What is going on? So. I could just bury it. If n lies on the circle, if only if I does. Because you can get a bury central coordinates of... It's a weird condition though. No, I think... do you want to use bury? I could use bury. It's kind of gross though. The interesting thing is, so far none of this actually involves x, y, or p. So I'm gonna hide all the mixed to linear stuff because right now I have a claim that doesn't seem like it depends on that. And I'm curious how it will tie in there, but right now it doesn't seem like it's important. Why aren't you trying to prove just concyclicity? Well, if you have an approach, I'd like to hear it. I don't see one yet. I'm trying to think like, it's sort of BFEC looks like a complete quadrilateral picture to me with two congruent sides. So, might want to draw the Bevan point. Which one's the Bevan point? It's like where the X center and stuff. I forget. I suddenly forget which one's the Bevan. Bevan point is like if I take the X centers and draw the altitudes to their closest sides, right? Gregorian looks like it's on the circle. Really? Wait, that's very strange. Okay, well let's draw the Bevan point. People want to draw it. V is 2 times L minus I. Oh frick. I used V already. Wow, would you look at that? Is it always on the circle? Oh, that's unconditionally on the circle. Wait, why is that? The heck? Why is that true? Okay, also this notation sucks. We're gonna repurpose this. Can you add X central triangle? I could, I guess, but I'm still... Something about this is bugging me, but I can't put my finger on it. There's something I'm not seeing. What does it mean for if I have a complete quadrilateral and this point N lies on this circle? Like just from the complete quadrilateral, 9-point circle right angle config with respect to X central. Hang on. Which 9-point circle right angle config? Wait, what did I miss? The heck? Wait, how'd you get that? Orthic triangle in center thing. I agree, but I guess I don't see why. Is it like AH? Oh, I see what you're saying. Like if I lies on it, then V does as well. I agree, but it looks like right now V lies on the light blue circle unconditionally, even doesn't pass through I. And that's the part that's confusing the heck out of me. Like I don't see why this is true. This doesn't feel like it should be true. Well, okay, actually, hang on. If I just draw the... Okay, fine, I'll draw the X centers. Oh, this is gonna be so annoying. Okay, IA equals 2 times M minus I. IB equals intersect line CIA. And IC equal intersect IAL line. Okay, so what's going on? This guy, this guy. Alright, fine, we'll draw the Bevan point. Why did we remove P? Because the claims that we're trying to prove don't seem to depend on it. So I want to figure out what the heck is going on first and then worry about P later. Okay. Okay, fine. Okay, it's true by angle chasing, yeah. This is... Okay. Okay, so V also lies on the circle. Wow, I learned something new today. This is the most weird circle I've seen in a while. Yeah, so Bevan point, this is how it's defined. It's like, this is a right angle because AB is anti-parallel to IBIA, and so that's the Bevan point. For people that want to know, it's the circumcenter of these three guys, and it lies on these three perpendiculars. In any case, this angle is now promised to be equal to this angle because they're both like 180 minus twice whatever this is. Bevan point. Okay, so V lies on there unconditionally. Oh, does that help me? I'm so confused why I is there though. So if N lies on AEF, then does something happen? It's like if BE and CF meet at a certain angle. Have I done a video intro? Yeah, briefly. Not a very elaborate one. Knockout line is B and knockout line. Um, knockout line is like in center Gorgon point centroid or something like that. Or I'm sorry, in center Nago point centroid. Yeah, that's what it is. So why is the in center on there? Like, so I know that these are all separate. Spiker. I never remember which one the spiker center is. Is AIVL a rectangle? Yeah, that's what's going to happen. Okay, actually, so I guess if N is on here, I don't want to show AI is perpendicular to IO. Oh, dang it. Oh, I see. It's this picture. The triangles for which this is true are going to be the triangles for which BC is the average of AB and AC. I remember seeing this kind of picture. I don't want to see AB plus AC equals DBC. And it's somehow tied to N lying on this. I just don't see why N is involved. Like, there should be something, but I don't see it. The spiral similarity at L will take... I could just bury it at that point, though. I could say by bury, like, N lies on AEF and then try to rearrange that into what it is. That seems very annoying. On the other hand, the condition that N lies in the circle can, I guess, be sort of interpreted with PowerPoint. Like, if I write Bn times Be equals Bf times Ba, is that reasonable? Yeah. Yeah, so I on there translates the pure line condition. So if it was a contest, you definitely just bury the N now. But I want to see if I can find a synthetic way to do it. Yeah, AI equals IM. So by basically what happens is by Ptolemy's theorem on ABMC, you'll get like AM equals 2BM equals 2CM. And yeah, it's just less math. Yeah, yeah. Yeah, so it's equivalent to AI equals S minus A. Maybe I should add in those tangency points again. This one? No. No, it's not S minus A, right? Is T1 the center of O and D? I doubt it. That's not a symmetric definition, so it's never true. Yeah, the problem is n. Like, n is the one point that I don't have a good interpretation for right now. And it's driving me up the wall. NB equals NC. Is that a coincidence? Honestly, it might not be. N is also equidistant. Why? Why would that be true? So it's saying like these snuggle angle. So B and MC is a parallelogram. Yeah. Okay, right, because so if I lies on here, then so actually I can show if I lies on here, then B and MC is a parallelogram. Because now this is equal to this equal this. And so this, like, this is an isosceles trapezoid, so this is a parallelogram, this is a parallelogram, now it's a rhombus, now you have 180 minus A. In the other direction, I'm not sure. Yeah. So I can actually prove the converse. I prove that I is on the circle, then N is on the circle. But I don't see how you do the other way. I do think this parallelogram's worth thinking about. I have a thing, and then it's oh god, that's so stupid. AF over AFB equals A over AC. Von Apple. You need to show AB. Now, this sucks. I have the converse. Freaking. No. No. I have the converse because the way I got the angle is because it's a parallelogram. Can I reverse that? If n lies on the circle, yeah, the reflection of the Nagel point. It just seems that's just really crappy. Is there anything that's true about n unconditionally? Like, is that... No. How do you prove the converse? Oh man, I hate this. You want me to add the medial triangle? Oh, that seems like a lot to add in. So if AEIF is cyclic, first of all, because the Bevan point unconditionally lies on AEF, it follows that AIV is 90 degrees, ergo I is the midpoint of AM. Therefore, by Ptolemy's, you get the length condition that you want. In addition, you also get n lies on here, because if, like, this length, if IM is equal to MB is equal to CM, then you get a bunch of parallel lines, which imply B and CM is a parallelogram, and that parallelogram gives you the angle that you need to prove the concyclic. But I don't see the converse. It's like conversely. I hate this. ADNO. Is that unconditionally cyclic? It's, I bet it's true in this configuration just because like everything seems like it's true in this picture. Yeah. Yeah, actually that follows by power of a point from M immediately. So MD times MA equals MC squared, which is also equal to M thing times ML. And then by halving and doubling it follows ADNO is cyclic. And so P lying on there. Fine, so now what? Why is the other direction true? If n lies on the circle. Can I use power of a point from M? No, I don't know. I'm not promised that n lies on that perpendicular bisector. Crap. Yeah, we need AB plus AC equals 2BC with n from n on being on the circle. And it's frustrating because I know that in principle I could just either bury it or throw power of a point from B at it. And it would like have to work. Just, because Bn times BE is like some multiple of BE, and so you get some condition. But I'm annoyed because I have such a clean synthetic proof of the converse, and I have no synthetic proof of the forward direction. If I have AB plus AC equals 2BC, then I is the midpoint of AM by Ptolemy's theorem. And that will give me eyes on the circle. Yeah, so I agree, like, I could just actually draw on the medial triangle. What's the medial triangle do? Nagel line? You want the fact that NG and I are collinear, is that what you're saying? Okay, fine. So MA was midpoint A. Okay, so here's the... Please teach how to solve hard problems. Oh, believe me, I wish I knew how. The spiker is the eye of medial triangle. I agree. So the spiker center is the triangle center MA, MB, MC1. Ew, wait, what the heck? Is it the midpoint of IN? The heck? Oh, okay. I did not know that would... The heck? Why is that true? Okay, well... That's true. Okay, so Noggle, fine. I drew the spiker center. Why does it help me? Okay, now draw the centroid. Okay. It also, I know that it also lies on the line. That tells you I is the Noggle of the medial triangle. I'm confused now. So unconditionally, those 4 points are always collinear. If n lies on the circle, what does that do? So the spiker center is the, let's see. Ni parallel to BC. I mean, I guess. Yeah, I agree with, but like, where's the circle condition being used? That's the part I'm missing. Like, where do how do I use the fact that n is on light blue circle? like, how do I use the light blue circle? BHNC. Okay, so the point is I take BHNC, I homothenate it to the medial triangle. Orthocenter goes to the circumcenter of the medial triangle, ergo the where does n go? Does n go to the... Oh, this is... Okay, so... n maps to I. So take the homothenate mapping n, b and c to... Thank you, Julian S, for the follow. BNC to MBMC I. This is homothenate at the centroid. I'm lost too. Well, we'll figure it out. So Wen says I'm supposed to take a homothenate at G mapping NBC. No, wait. Is the center at G? Yeah, it's center at G. And it will take... MBMC I, and so I lies on the... What the heck? Does that work? Are you freaking... That's... Okay, so actually ignore the spiker point and ignore... Yeah, ignore the spiker point. So, here's a circle. This circle is called B and C. I'll draw in orange here. So, this is the reflection of the circumcircle. Actually, ignore... Okay, ignore the Bevan point. Also ignore I for that matter. We don't need that for now. Here. And ignore M sub A. Ignore... And we might need V later. We'll leave it for now. Okay, so the flow of the logic is this. By hypothesis, we're given that B and C lies on this... Like, B and C has angle 180 minus A. So this orange circle is the reflection of the green circle. And the not-go line is the line through I, G, and N with G in a 2-to-1 ratio. So what this means is that I can map this orange circle through G as follows. B goes to M sub B, C goes to M sub C, and N goes to I. So A, M, C, I, M, B are cyclic. Ergo, I is the midpoint of I, M.
I didn't hear that. Please try.
What the heck? Wow, okay, that works. So ergo A, M, B, M, C. So I bisect AM. So then it follows that well then everything follows. So now I is the midpoint, and let me flow the logic. So BC is the average of AB plus AC. And now yeah, I'm not worried about P yet. I mean, I assume once we have all the stuff we want, then P is the easy part. Okay, so if that's true, then okay, let's hide the orange circle again. Why does that lie there? Hang on. How do I get I on the light blue circle? Man, I had to... I didn't write it down. Oh, crap. So if I is the midpoint... Oh, yeah, I lies in the circle because the Bevan point is like... Okay, A, L, V, E, F are unconditionally cyclic, and then OV. Okay, so now... So since IVO are unconditionally collinear, and V lies in AEFL, now I lies on the light blue circle. And so now we get, great. And now hence BF equals CE equals MI, but now MI equals MB equals MC, and that gives us like 5 equal lengths, so now N is that. Okay, cool. So we have everything we ever wanted. Yeah, amazing. Okay, cool. So now let's actually deal with the mixed linear stuff. So I gave you a proof earlier that AD and O are cyclic by power of a point from M because, yeah. AD and O cyclic. Great. And so now we just want to show that circle passes through the mixed linear touch point, which up till now has been not doing very much, but let's bring it in. Okay, so AD and R are cyclic and we want P to be there as well. What angle can I go through? Please teach how to get non-zero score on AMO. Usually you get a non-zero score by solving at least one of the problems and just turning it in. Yeah. I don't know. Okay, so AD and R cyclic. Right, what were you trying to do? So AP is... So PL is a thing. And ML is also a thing. What do I do? Which angles do I control? D is circumcenter of PIO? I would believe that. Or, sorry, PIM. Yeah, okay, so D is promised midpoint of IM, right? Is that true? Yeah. So IN is promised perpendicular to NL because of, yeah, okay, so let's draw that circle, that looks good. And, okay, so we have a bunch of right angles there, fine. And how does that help me with the cyclic? Wait, done? Wait, why is that? Wait, what did I miss? Oh. I is the in-center of APN, is that what's happening? No. Wait, I'm confused now. Angle tracing for which angles do I flow through? Is it? Oh, can I compute PND? Is that what's gonna happen? No, PND sucks. PDN and PON. Oh, fine. Yeah, that works. PDN is... oh, I have to be a little careful because of the doubling. Um, let me use DPN. So like DPN is equal to like 90 minus and DPO. Should I use DPO? Oh, whatever. Oh crap. Yeah, wait. Let me actually make sure I don't botch the ending. How can I deal with this in a way that I don't need to deal, like, have any angles? DPN should work, right? Yeah, okay, that's a 90-degree angle. PML. Why am I off by a factor of 2? Wait, what do I do about the doubling? PDN. Okay, let's just embrace the double. PMN. While PL n is equal to PLN is twice angle PLN. Okay, we're fine. Twice angle PLN equals PLN. Okay, we're fine, we're fine. Alright, so that's part A. And part B, PD is equal to DM is equal to half I, MI is half equal to... Yeah, so the second condition is saying that, like, S minus... PD is S minus A over 2. So the problem condition is saying, like, S minus A over 2 is equal to 2/7 A. And also, like, A equals half B plus C. So for the second half, okay, someone help me with the answer extraction. So S minus A over 2 is like B plus C minus A over 4. Hang on. What? Wait, don't these contradict each other? Did I screw something up? How is PD S minus A over 2? Oh. No. So PD was... So this is a circle with diameter IM, right? So PD is equal to DM is equal to IM over 2. And IM was supposed to be equal to BF because it's isosceles trapezoid. And this thing is S minus A, right? Isn't BD against DC3? Wait, am I crazy? Like PD is half of IM, right? Oh, I mean, if I wanted to solve this during the test, I would just throw Barry at it. Like, it's just, it's a Barry problem. Oh no. But I'm confused now. I don't get IM equals BF. IM is equal to BM, or IM is equal to CM, because M is always a segment circle of BIC, and BM CN is a parallelogram, so BF equals CM, right? But I'm confused now because this seems to say, like, PD should be equal to, like, half of BF, and BF is equal to S minus A. So I'm confused at how these equations are consistent with each other. Like, it seems like they just contradict each other. So I'm messing something up. Why is 2 angle PLN equal to PON? By the inscribed angle theorem. Yeah. Like POM, really. Wait, hang on. No, what's with the second part? The conditions don't match, right? Am I crazy? No, it's not about batch. Like, one equation says A is the average of B and C, and the other equation says B plus C is equal to, like, 15/7 times A. Like, they're not compatible. Right? Am I being pranked? No, 15/7 is not 2. What? No. Hang on, what is going on? The heck?
Rather, it's about tending to the broken parts inside of ourselves. We create things as a reflection of this struggle.
If my triangle is equilateral, then PD over BC is what?
That way,
Something, I don't know what it is. No, I'm very confused. Why do these... What did I mess up? IM is equal to MC is equal to BF. BF is equal to S minus A.
constantly strive toward.
S minus A
This all comes from
over 2A.
that ideas aren't static, but fluid, like water. Be like water.
What the heck? Hey guys, help me finish the problem! We're almost there! I just need to do this dumb answer extraction. What did I mess up? BD. PD is it's just minus A over 2. Okay, wait. If I make this an isosceles triangle, where's the mistake? Let's make this equilateral. Alright, let's make it equilateral. Let's move this here so there's a well-defined midpoint. Now I'm very confused. Am I wrong about it is a parallelogram, right? Like BF. Like BN seems as a parallelogram, right? I'm not making that up. Yeah, these are parallel. So BN is equal to CM. Or BF is equal to CM, right? And what is up? Oh, God. Okay, never mind. I see the mistake. CM is not equal to BF. I'm just stupid. Alright, never mind. It's IM. Whatever IM is. Okay, let's try that again. So, I'm told that IM over BC is something. And I also told an averaging statement. So IM over BC equals 4/7. What's the explicit formula for IM? It's like so BM is going to be equal to what? So we're given BM is 4/7 A, and by the law of sines, it's equal to 2r times sine A over 2. Okay, and the circumradius is A times sine A, right? Okay, so this is true. And if this is true, then we can use this to... Something feels weird to me. The sign, shouldn't the signs point the other way? It's A over sine A. Yeah. Okay, so if this is true, then I can extract the value of cosine A. So let's see if I am not incompetent. So... the double angle for sine is 2 sine A halves cosine A halves. So 4/7 is equal to the reciprocal of 1 over cosine A over 2. So the cosine of A... The cosine of a over 2 is 7/8. And finally, the cosine of a is equal to twice 7/8 squared minus 1, which is 49 times 64, 98, 34 over 64. Okay, 17, 30 seconds. Okay. We made it. Someone please tell me whether that answer is correct. I also have 17, 30 seconds. Okay, cool. Alright, let's write this up. So as I promised, I'm going to start doing write-ups in this stream rather than offline because otherwise I never get to them and it takes forever. This also has the nice effect that if I make a mistake, hopefully I will find out earlier rather than later. Alright. So okay, so let's copy the diagram. So I'm gonna move this diagram around so this stuff is that's a good snapshot. Okay, so let's hide the accenters because we don't need them. We didn't use those in our proof. I also want I to actually lie on it, so let's... Okay. Algebraic geometry is sometimes useful in Olympiad problems, but in my opinion, I don't know. Algebraic geometry is also just like really hard. Like I feel like there's almost no justification to like learn algebraic geometry for relevance to Math Olympiads. Properly anyways. Like I think it's good to know that cubics intersect, like two cubics probably intersect at 9 points or something like that. But some of these labels are not well placed. So B should be here, C should be here, this direction, F should be out here, V is down here. Okay. Okay, so let V be the 7-point, G be the centroid. What other points did we define? We didn't actually... Okay. So claim... The big claim is that the point I is the midpoint of AM. Well, let's see. Unconditionally, V is the midpoint of IO. V lies on AEF. V is the antipode. Actually, V is the antipode of A on AEF. How do you spell unconditionally? A on AEF, and G lies on IN in a 1 to 2 ratio. So proof of this is we are given the angle, directed angle ENF equals directed angle so the reflection, so we may take a homotopy of ratio minus half centered at G, which maps N to I, B to MB, C to MC. The resulting circle is known to pass through A. Thus, since A, M, B, M, C need I, then I is the midpoint. Okay, and now claim I lies on AEFV and BMCN is a rhombus. Okay, so since I is the midpoint, it follows void perp AI, so hence the first part. For the second part, what we say is that the spiral for the second part we let L be the arc midpoint. And M and N. Second one, I'll be the arc midpoint. Okay. For the second, and then the spiral similarity L maps BF to IM to CE. Since BF equals CE is a congruence. Also, BI equals IM equals CM. So we get BF equals CM. Oh wait, that does not give a rhombus, right? Does it? That's not good enough to promise a rhombus because F is not on the circle. Oh crap. Alright, so this is why it's good to write up here. So okay, so I get all those congruent lengths. Actually, oh, it's actually not parallel. Wait, it's not a rhombus at all. What am I talking about? Semi equals C. Wait, okay, so I better make sure the finish of this is legit then. Okay, so ADNO cyclic we disagree was from PowerPoint, right? So are we promised yet the N is on line MO? We are not. MI is not equal to BF is equal to... Wait, is MI just not equal? LI is not equal to... Oh, shoot. Wait, okay, so I am just being really... I'm just clowning. Alright. So the answer extraction I had... Okay, so... oh my god, today's one of those days. Everything I write is wrong. Yeah, you're right that, okay. Yeah, so LF, LI... So MI is not actually equal. So, that means this answer extraction is garbage, first of all. This is all just wrong. And... Alright, so what am I doing? PD. Answer extraction is right? Oh, I guess so. Okay. Yeah, it's not. Okay. Yeah. But I guess the thing is, how do I show n is on the perpendicular bisector? Like, I want this to be a kite. It's not a rhombus, but I want it to be a kite. No, the answer is actually okay, because I used the correct thing. I'm just confused why... Is it... Wait, is there... Okay, let me check the diagram. So I had this fake proof that... How do I know n is on the perpendicular bisector? So I have the midpoint thing, and n is the intersection of angle parts. I think that the yeah, actually, how do I show BNCM as a rhombus? I guess that's what I'm trying to do. I want this to be angle A over 2, right? Homothency at back through G. Oh, okay. Yeah, you're right. No, that'll work. Okay, that's fine. So I is the midpoint of n. IME equals IMC. Oh my god, I am clowning today. Okay, so n is there. That's fine. Now I want it to be so... Okay, so now since MA equals 2MI, it follows by power of a MA equals 2, MI equals 2MB. It follows by shooting lemma that MD is half MI. There we go. And then we have directed angle INL directed IL is 90 degrees. So you find that N is actually NBMC is a rhombus. So this guy here is a rhombus. That's fine. Finally, to show okay, so that's actually proof part 8. We compute the directed angle of PD claimed. So D is the center of I am. So D is the midpoint of. Yeah, I'm garbling everything. Okay. So we compute the following angles. PDN is equal to 2 twice angle PMN, which is twice angle oh my god. Really, nothing I'm writing today is correct. Twice PM. PLM, and twice directed angle PLM is directed angle POM. Note that ADON is cyclic from power of a point at M. Now we compute this, and that'll do it. Okay, and then for part B, well, I'm thinking probably just since DP is equal to half MI, we equals half MI equals half MB. I just take this calculation. Okay. Okay, there we go. Alright, solution done. It looks so short once you've actually written it down. Boom, boom, boom. And then here's part B. We did it. Alright. So the mixed linear in circle did mostly turn out to not be relevant, as I predicted. Like, all the claims didn't depend on the mixed linear, so that was nice. I was surprised at how much of a role the Bevan point played, but I guess that makes sense given the X circle touch points. Yeah. Alright, cool. How long did that take? It's like 10 already. Oh lord. Okay, well, next problem. So the next one on the list is supposed to be 2020 B6. I'm concerned I will not solve a problem given in like any reasonable amount of time. Whatever, let's give it a shot if you want to see it. If we manage to solve it, I will be very happy. I don't think it's gonna happen. Why is geometric algebra not included in napkin? What is geometric algebra? Yeah, this is from CHMMC 2021. It is the stuff with bivectors. Probably because I don't know it then. I think to a very first order approximation, napkin is exactly the set of higher math I know. So if something isn't been written about in the napkin, I probably know very little about it. Maybe the only exception is I didn't write up analytic number theory stuff, although honestly I should because it would be good for me. But I have not been very productive for the last year. Hildebrand's nuts, I agree. I think what I'm thinking about doing is I want to write a part of napkin about L functions and Mellin transforms. So I'll probably like get the prime number theorem as like a byproduct, but I start use it. Basically what happens is yeah, Hildebrand is actually pretty non-scary. How often do you add units to Otis? It's been less and less. Like the first few years I would write units very regular. Actually, the first couple years I did Otis, the number of students was so small that I wrote units per student. Like I would write a unit for each I would write the units for each individual student. Obviously that's not possible anymore. Like at all. Are you gonna try any of the Millennium problems? Not anytime soon. What are we doing here? Oh, I was about to start a problem, but I got sidetracked by chat discussion. Yeah, I don't know. I don't see what I put in, but let's give it a shot. All right. The people kept voting for this. Combo games unit? That's honestly just the process unit. Okay. Welcome back, everyone. So I've been asked to do this Putnam problem. I'm not optimistic, but we'll give it a shot. So this problem has to show that this random sum is non-negative. If you take away the layer, what this says is let's just let like a sub n. Actually, yeah, let's use n. The n in the problem doesn't matter. Well, let a sub k. Okay, fine. We'll use k. Well, let a sub k equals this thing. And my goal is to show that all the partial sums of this sequence are non-negative. Yeah, BID. Okay. Alright, so what the heck do I do with this? There's like nothing, just no, there's like no footholds at all that I can see. Let me write out the first few just to get a sense of where they are. Okay, point, yeah, I feel like BID might be the right thing, but the problem is I don't actually remember the statement BID. 0.414. I'm also counting. 828, 124. Yeah, so it goes back to 0. I don't know. Okay, so what do BID sequences say? BID sequences promise me that let's see, floor of k root 2 minus 1. So BID sequences don't work with numbers this small, right? Do they? Is it this one and the other one? Yeah, I think it's like k square root 2 and well, that was a whole lot of nothing actually. Let's see. Oh no, I'm just computing it. K square root 2 and what's the other one? Actually, so here's what I'm gonna do. I'm going to, because I want to use BID sequences, I'm going to let one of them be k times square root 2 plus 1. So this will have the same parities, but it will have a complementary sequence by BID's theorem. And BID's theorem is like 1 over alpha plus 1 over square root 2 plus 1. Okay, and I am a mathematician, which means I have no idea how to do calculations like this, but let's give it a shot. So this is square root 2 minus 1, right? And so what is the sequence? It's like alpha equals 1 over 2 minus root 2. I can't even spell. It's equal to 2 plus root 2 over 2 equals 1 plus root 2. Wait, what? No, that's not correct. I am a very capable budding mathematician. What is alpha? Can someone help? Yeah, so we're definitely switching to root 2 plus 1 so that we don't get repeated junk. But for some reason, I cannot find the value of x such that 1 over alpha plus whatever. 2 plus square root 2 over 2 is not 1 plus square root 2. Oh, okay. Yeah, that seems to be an issue. 1 plus half root 2. Alright. Okay, so the BID's theorem says that these two sequences are complementary, meaning that every term appears only in one or not the other. Now I'm gonna delete this because this is irrelevant. We're gonna use plus 1 so that BID actually applies. So that is a random fact. Today I learned. These two things will be complementary. Alright. That's fine. Now the question is, why would there be more even things in the first sequence than in the second one at any given threshold? What's the relation between these two? One of them is like square root 2 times the other one, right? Yeah, so the constant here is pretty special. It's like... That being said, I wonder if it would be easier on me if I picked a bigger number or something. I don't think so. Hello. Yeah, like I'm looking at this and I'm seeing the fact that like this alpha, we'll call them alpha and beta. How about that? So we'll call like alpha is k root 2 plus 1, or root 2 plus 1. And we'll let beta equals root 2 over 2 plus 1. So we're looking specifically at the sequences floor of alpha k and floor of beta k. Yeah, I agree. It's very interesting to me that these sequences have ratio 1 over root 2. I don't know what to do with that though. What can I do if they have ratio square root 2? It means that I'm gonna get my iPad. I have an idea. Can someone actually will anyone be annoyed if I like have a computer grind out the first several turns for me so I don't have to compute them myself? 'Cause I don't feel like computing them. Come on. Crap. My tablet. No! Work! You are technology! God damn it. Oh, I just saw the OEIS link. What does this paper say? Oh my god, this is the worst typesetting I've ever seen. I'm not okay. Well, I'll look at that later. I have a feeling that it's a bit of a spoiler to look up something that's like that directly related. On the other hand, my idea is something like the following. Oh crap. Oh, come on. Where's my board? Evan Twitch Public. There you go. So, alpha line and beta line. I have a sequence, so I guess for example, the first few terms of the alpha sequence, the first floor is 2. So this is like k equals 1. And next one is, so let's say 2.4 and 7. So for example, those are the first 3. And then on the other bottom, basically the premise is that there's, okay, so the bottommost sequence is, alright, let me write the decimal approximations out. So this one is about 2.414. So this one should be about 1.707. So this will give k equals 1 here. K equals 2 is this one. K equals, so it looks like this. So far. And I want to see if I can, so these are related by a factor of root 2. So the it should amplify by root 2, whatever that means. But if I take for every even number here, like if I have a 2 here, if I have a 2 here, I can draw an arrow like this. I'm not sure what I'm getting at. So I'm trying to do something here. Right, no, this should go to 4. Where I'm like multiplying the thing inside the floor by a factor of square root 2. I don't know if it's gonna go anywhere. This is just an thought that I had. I feel like the same should be true. No, it doesn't require. This doesn't require even. This should work for any parity. Okay, let me write more terms out. But basically, I'm seeing this thing that these things have like a factor root 2 in common. So I want to see if I can like join them up somehow. So let's see. 7.2, 7242, 9656, 12.07. Okay. And then on the other bottom, it's like 5, 6, 7, 8, 9. What's the next one? 14484. So like for example, this 3 might go to like this 6. And there's a sort of zigzag that should happen like this, where I have this thing, and in each thing I'm like amplifying it by the square root of 2. What is ECMO 2018-3? Is it that? I put that in formulas? Really? I thought I put that in process. Maybe it's a typo. Did you have any problems in mind? Search for IMO 2017-6 arithmetic geometry. 2015-5. Yeah, that sounds right to me. Here, I'll put it in the chat. With square root 2 directly? I don't see why it would help to do it with square root 2 directly, because the thing you get doesn't have the same thing. But I feel like these arrows, like, they should... Basically what happens is that the numbers should all get put into chains, and the chains are being amplified by square root 2. And I don't know. Like, part of the reason I'm doing this is I just can't see, like, what else is even reasonable to do. Like, what else are you gonna do? Like, you have the square root 2, you don't know anything about its binary digits. But here I at least can say, like, you know, I have a chain spawning from all the odd indexes on the bottom, like this one and this one. I should change this to be... yeah. And the square root 2... yeah, so the root, I feel like the root 2 scale should do something, right? Because it's saying, I don't know what it's saying. What's the relation between floor of x and floor 2x, where x is a real number? For 2479 are... what about 2479? No, it's 4 root 2 plus 1. It's this one. So the alpha sequence I have on the top and the beta sequence I have on the bottom. If I graduate from Modus this year, will it be okay if I stay in your server just to troll? You can stay in the server, please don't troll it. Yeah, so like, what is the relation between... So, I guess like why would I want to switch to square root 2 times n4? Like, this doesn't seem like... Like, it now has the advantage that I am now confused about... Now you have to keep track of like parity. And... Wait, actually now I'm confused. What is it? What are you proposing? 2, 4, 7, or 9 are also when the original exponent changes. Wait, no. What? K equals 1 to K equals 2, K equals 3 to K equals 4. Well, I mean, I guess. Yeah, because, I mean, these two sequences are the same up to parity. Right? So, can we use that? What would that do? Like, the original sequence is like... All we've done is shift it down by 2k, I think? Or something? Like, yeah, I agree the change points are the same. But... I guess I don't see what it does for us or something. Like, it feels like it's also just a restatement of like, in some sense, like this problem is about a fixed sequence. Like this, it's about the sequence 2, 4, 7, 9, etc. And self-define. Actually, I kind of see what you're saying. Which is like the original problem is like, in the original problem, these are like the zeros, these are like the ones, and then these are like the twos or something. And you're asking about like the parity of the step size. Or never, like the even index step sizes or something like that. Fairy things? I feel like fairy doesn't work with irrational stuff like this. Are they Euclidean? Oh. Yeah, that's the only one. Geico Lizard has a link. Sorry, I didn't realize you wanted Euclidean. I just want to motivate myself to learn higher math. Okay. Oh man. Okay, wait. Would someone like tell me does this do anything? Like, I feel like I have this. I have these chains. I don't know what to do with these chains. Every number is in a chain. Also, in any chain, okay. So when I go from like 2x to like 2x or x to 2x, this is always equal to either like twice the floor of x or twice the floor of x plus 1. So when I follow the chain from the view of the top, this is either doubling or doubling plus 1. My hope is it's not double plus 1 too much. The same is true on the bottom. It's either double or double plus 1. Thank you, HH sub V. But depends on whether the index appears in the sequence, yeah. Why should I believe EGMO 2017-4 is true? Because there's a lot of... No, just do the problem. That one's... There's no trick to it, you just kind of construct it. Like inductor, like you can just kind of for the EGMO 2017-4, like you peel off T1 and Tn and then go. How did you find out about Barry? James Tao and Max Schindler were talking about it at MOP, like I forget what year. So sometime between 2011 and 2012. And so I kind of sat down and worked out the entire theory, and then what was it? How to peel T1 off. You just do it. Because what if things don't add up? Why do you care if things add up? Like you necessarily have some like universal vertices, right? Like some vertices that are like isolated slash universal vertices. So the only you don't get to make many choices. You just kind of I don't know like okay. Anyways, where was I? Do you think there are still more worthwhile bashing techniques that haven't been discovered yet? Maybe. I'm not really sure. Euclidean geometry is kind of a weird situation because it's a given infinite computational power, you can do most problems, but so the limits are more pragmatic than theoretical. Okay, let me actually think about this. So actually, when I follow a chain, the parity of it feels like the parity of the next node in either line like doesn't super depend on. I don't know. Like it feels like it doesn't really depend on the previous number in some sense. Like if I'm looking, you don't care whether 4 is even, in the sense it's either 8 or 8 plus 1. No, don't generalize the induction hypothesis, just do the problem. Like, you don't need to generalize it. You just need to induct by two things out, like T1 and Tn at once. Can I work with rational instead of root 2? I feel like the problem would be completely different with the rational number. Like, I don't see why knowing how to do the rational case. First of all, it's probably not true for a lot of rational numbers. And I like don't. Okay, there's a hope that yeah these sequences don't work. For example, there's a hope that we could do something silly like, you try to approximate root 2. Yeah, you try to approximate it by a rational number that's close by. But I don't know about you. I don't know how to do rational approximations of square root 2. Thank you, cyanide for dinner. Follow. Is it true for every rational number? No way, right? Like, just take like 1.1 and it's just like false. For like n equals 1. One-digit product table. What is a one-digit product table? If n, for example, 1000. We need only 5 digits. Yeah, so that's what I'm saying, right? Like, you could try to say for any n, we try to take a rational approximation that's close enough that it doesn't matter for, like a specific value of n. However, I don't know how you would say something. I guess I don't know how you would say something about the like that rational approximation. Like, you know, you need some property of square root 2, minus 1. One till 9 times 1 till 9 simple elementary product table. I don't see why base 10 should be relevant to this problem. If anything, I think you want to look at base 2, right? Because you have a square root 2. Like, I agree if you can show like there's I agree that like these claims would be sufficient to solve the problem. I just don't see like how the claims look any easier than the original. Like all the like rational approximation claims. Like in particular, like you need to use something about the number square root 2 minus 1 or whatever, right? Like the like you need the actual constant. And I don't know what property that constant should have. Thank you, sandwiches with cheese for the follow. Right number plus ones and minus ones is a function of k. Probably not. I mean, I would be delighted if you could, but I don't see it happening. I don't know. See, that's the reason that I've been like drawing this arrows picture, because this arrows picture, when I pair it with the Beatty, like does give you something. It tells you that there's some doubling thing happening. But it's not clear to me. Yeah, like this at least like uses the fact that it's like square root 2 minus 1, right? Because what you find is that when I move 2 steps in this arrow, the number doubles, and that's an integer, and so maybe something is going to happen. I don't know. But it at least uses the square root 2. Whereas like here, like there's a lot of things that are being suggested that like don't use facts of square root 2, and I'm basically convinced that if you don't use properties of square root 2, the solution will not work. I would also not be surprised if it was based on the continued fraction. That is also on the table. Is there a sense in which continued fractions of are there's a sense in which continued fractions are the best approximations, right? So okay, fine. Let's look at this. What is the continued fraction approximation of 1 plus root 2? Can someone? I don't actually know what it is, but someone's got to tell me. 2 plus 1 over. Ah, crap. Yeah, let me just use Wolfram Alpha. No, continued fractions is not a Taylor series. That's completely different. So root 2 plus 1, the continued fraction. Oh, wow, that's a very simple continued fraction. Okay, so I can get arbitrarily good approximations of square root 2 Oh, I want 1 plus square root 2 because that's the one that is like b at e, wherever. So, okay, that's fine. So if I look at the continued fraction approximation, the convergents are like first approximation is 2, then it's 5 halves, and then it's like 12 fifths, I guess. Then it's like 29 twelfths. So okay, so my first question is there a closed form for like this sequence? There really ought to be. Let me just plug it into OES. There should be a closed form. 2, 5, 12, 29. Damn it. It's Pell. Right. Alright, but the point is, like, if you want to do rational approximation, fine. But these are the fractions you want to use. You want to use something about that. Okay. Second question: Does the property hold? Does the property hold for each of the fractions? Okay. Apparently it doesn't work for. No, this was actually okay. So this is always okay. 5 halves is like 2.5, 5, 7.5. Yeah, actually, I believe that these should work. There's a sense in which if they didn't work, then probably some initial segment of square root 2 would fail. Because these things approach square root 2 really rapidly. Yeah, they should actually all work, just by looking at them. It sounds like they're good. Okay, fine. So people who wanted to use evenness, to use rational approximations, yeah, each one is a denominator of the previous one. I agree. So is it the can I show that there is more even things here than not things here? That actually seems plausible. It's interesting because some of them, so there's some of them have odd denominator. If you have an odd denominator, it promises you that that what it'll actually be tight with like 12 or something, or something. The Amy math jam has been going on for 4 hours. Okay, so fine. This might work. How do I do something with these fractions? This could work. This actually could work. I wonder if it's the case that no, that doesn't make sense. So the benefit of being rational is that there is a bit of symmetry, like it goes backwards in some. How fast does this grow? It grows by a factor of 2.4-ish. So this part will be a copy. The initial segment should roughly be a copy of the previous segment. Like I'm willing to bet that like for example the first 12 terms of this will match the first 12 all 12 terms of this up to the last one. The problem is the sequence grows rapidly enough that that's not good enough. I need something to deal with the things in the middle. I think the key is we start from 0. What do you mean we start from 0? Which thing starts from 0? Quadratic. If we add 1 to square root 2 plus 1, then we flip all the parity. You're claiming the ones with odd denominator will work. That's, I mean, I believe that, but... Alright. See you 3v2. Seven-fifths? Wait, the 7/5 fell? No, I didn't. What? What do you mean 7/5 failed? Oh, the others failed, okay. Oh, 5 halves will actually fail. Oh, I see what you're saying. Right, because the next term in this sequence is 7.5. So this is like minus, plus, minus. So it's possible we're going to have to claim just the odd. Wait. No, that's actually really bad news. The odd denominator ones failed. Is it because this... Okay. Is it like one of these is an overestimate, the other is an underestimate? What game are you gonna play? At the rate I'm going, I don't know if I'll get to play any games today. Yeah. We'll see. Someone figure out how to do this. Jeez. Yeah, it looks like the odd denominator... Wait. What? 239 over 169 works? Are you serious? What the freak? Okay, I don't know what's going on with these irrational numbers. Someone had an idea that if I took this sequence and increased it by... Like root 2 plus 2 is like... I don't know. But I have to do something with the square root too, right? Like... What's wrong with T1 equals 2? No, you add multiple universal vertices. Like the first step does not mean you add a single vertex of with Tn. You add more than one. Anyways. Oh, crap. This one is 14.2. What do you mean what's wrong with a single universal vertex? Like, it won't work. You're finding that it doesn't work, so do something else. Oh yeah, that problem is really tough. Oh my god. Freaking... There. Why did I do this river too? Done right now. I mean, I'm just kind of staring at the problem right now. Like, I feel like this doubly, like, I feel like the two basic lines you have are, one is that you try to use the continued fraction of, one is you use a continued fraction of, like, square root 2 in some way, and the other is this thing where I'm drawing with the arrows where the things, like, double. Evan, is storing EGMO solutions on overleaf fine? I guess so. So I honestly, I didn't like any of the anything I could find, so I actually wrote my own software to store databases, or to be my problem database. Like, I just wrote its thing in Python, and that has worked very well for me. But it also is a pain to set up. So, yeah, I don't see what I'm. Is it pub? Yeah, so you can actually find it on GitHub. I'll send the link. Yeah, so this is the software, but it's like command line software. Like, if you aren't used to using a terminal, then it probably is not that useful for you. Yeah, I don't know if it'll be useful for me to keep working on this, honestly. I don't know if I'm getting anywhere. Like, I think the Beati is probably... You want even numerator and odd denominator. Oh, okay, so maybe that line is possible. Wait. Odd number. Is odd number odd denominator? I'm confused now. So is 12/5 good? Or I'm not sure what you're suggesting. Is Beati? Well, I just grabbed it Beati because I didn't know what else to, like. I don't know. Claim all fractions even over odd less than 1 should work. Yeah, that's what I was saying. You don't have only one vertex of degree Tn. That's why I said you want multiple universal vertices. No, someone's asking me for help on a unrelated problem in the chat. Is the claim that even over odd? I find that hard to believe though. Like, just even over odd is good enough because like there are real numbers for which the statement is false. Maybe those real numbers. No, that doesn't make any sense. Like, you don't expect a statement like this to be true for a random real number alpha. So what would need to be true? Like all the. That could be possible. No, that's not possible. No, what? No, hang on, now I'm confused. Okay, you know what? Let's test this. Yeah, I would be happy if it turned out that the only thing we needed about this thing was that its continued fraction convergence do a good thing. If that turns out to be true, I am so happy. I don't think it'll be true, but it's worth a shot because I'm out of ideas. So, ladies and gentlemen, I present you Python. GVim. Tried apart. I don't know. Yeah, I agree it should be possible, and let's see if it's really true that F P Q. Okay, so we'll let n equals for k in range 0, 2 times q. So s equals 0, and then we'll look at like k times p. A is this integer, and if a is even, we'll increment s by 1, else s minus equals 1. Okay, and if if s is strictly less than 0 at any point, we fail immediately. Return false. Otherwise, return true. It's probably, let's go to 4 times q just to be safe. Python. Oh crap. Okay, so for example, we'd like to see. We're hoping that 12/5 was one of the ones that. 12 of this works, but 5 halves should fail. It did not fail. Oh, that's bad. Freaking. I'm so bad at programming. Ah! I hate code. 2, 5, 7. Oh, frick. This is supposed to be one indexed, right? Yeah, that's important. 5/2. False. Okay, that 12/5 is true. Okay. Wow, that is a lot of ad breaks. Okay. Wait, how long goes this? Did I miss? Alright, okay, we're going to take a... How do you guys have so much ad break time saved up? Okay, we're gonna take a very long ad break while I try to figure out the code. Shout out to... No, that wasn't just a highlight, never mind. Okay. V-Bucks inflation. Headphones are too big for it. I don't know how Windows does this. Let's do this. Alright. So apparently I cannot run the other 60 seconds of ad break yet because I recently ran a commercial. So here we are. But let's get back. So this is where we were standing. We had this stupid Python script, and how often do you cut your hair? Whenever I go home and my parents force me to. I kind of want to grow out my hair and have girl length hair, but my parents keep making me cut it every time I go home. So my agenda is to go home as infrequently as possible, so I can avoid getting my hair cut. Okay, so what were we hoping? We're hoping that if I have what parodies? Like so 29 over 12 fails, but 12 over 5 will work. And their claim is that maybe in general, whenever I have an even... No. So there's something that... I do need something about the size. Is the claim that if I have a number less than 1/2 and the numerator is even, then it's true? Let's try it. So if I do like 4, 101, it's true, 4, 103 is false. Okay, so never mind. It's worth a shot. Sad. The only streamer when commercials are part of the entertainment. Yeah, this stream's kind of strange. I don't know why people request ad breaks, but they do, so okay, I won't complain. Okay, so... Yeah, so you need something about the fractions. You can't just pick like a random fraction. Like a fraction, like 5 over 103 failed when 5 over 101... Or sorry, what was it? What numbers did I pick? 4 over 101 and 4 over 103 are different results. And, stream is much more tight-knit. Yeah, I mean, MathCounts community is not that big, in some sense. I mean, like, the set of people who can really work on Olympiad-level problems is just not a very big set. So, there's a sense in which a lot of people know each other. That's one of the nice things, I think, actually. Alright. I don't think I'm gonna... I don't... What do I do with this, doubling? Can I do something with this doubling? Like 2, 4, 9... If I arrange them in chains like this, do I get anything out of it? So, actually, I really need to use the fact that it's, like, meshed like this. Like, it's not good enough to just, I don't know, man. Alright. Yeah, I'm pretty ready to... Alright, decision. No one wants to follow the arrows idea. Nuke just found progress. Wait, did I miss something from Nuke? What did Nuke say? Square root 2k and square root 2 and their average is the sequence we want. Oh, sorry, I didn't say that. Okay, let's see what this is. What are arrows? How are they useful? It's that diagram I have on the left. Um, so, right, so square root, I agree, square root 2k and their average is a sequence. Okay, so you want to do this with root 2k and root 2 plus root 2k. That's reasonable, we can look at that. So 1, 2. Yeah, I agree. I agree. Like, I totally agree. Like, we need to. You really use the square root 2 somewhere, and I just don't see where. So I'm willing to take anything right now. Square root 2. So this is the square root 2 plus 2 line, and this is the square root 2 line. So 1.414, 2.828, 4.5656, 770. Okay. And then this is 1, and that's 2. And select 3. And your observation is that these guys... Oh, jeez. See, the problem is that even if you know they're the average, it's not literally the average of the numbers, is it? Oh, no, it is, because their fractional parts match. Okay, fine. So... Right, so it is literally 2, 4, 7... Fine. An easy way to commute sequences to... Okay, so I agree. So we have some sort of partition, and... Yeah, it's like the average of them, so... Yeah, we also know that these blocks are always in chunks of 2 or 3. Yeah, okay. Okay. So... Okay, I agree actually. So that actually gives us a pretty fun recursive description. I actually like this. So like when you phrase it this way, it doesn't seem like a number theory problem as much anymore. So the procedure is we write so number line 1, you jump across by 2, you circle this. And then you look at the next one and you go like plus 4. And so on. And then for this one you go... let me not draw the circle actually. Yeah, actually this is a good description of the terms. This feels a lot more combinatorial. So... Yeah, so this is... Yeah, this is a way you can capture the square root 2 and get rid of the number theory. What we've done is we've used the Beati property and like... used it to write a combinatorial description of the sequence. This is good. I like this a lot. So this one, for example, would be like +6. Go that all the way here. And then this next one would be like +8, and it would go like... And that way you generate the sequence. So the... feels like a sieve, yeah. Okay, well now we're back in business. Now I finally got rid of the square too. Thank you, Nuke. That helps a lot. So what can I do with this? First of all, I feel like I've seen this somewhere before. Like this general process feels a little familiar, but I can't put my finger on exactly where. What is the rephrase question now? So I consider the following process with a number line. I take the smallest unused, for the ith step, I take the smallest unused number and draw an arrow from that number to that number plus 2i, and then repeat. So this is step 1 is this green one, step 2 is this red arc, step 3 is this green arc, step 4 is this red arc. And in this way, I generate a bunch of arcs on the circle. And you would like to show something about the parity, like the, yeah, we did something like this. What was that Fibonacci, the BMO problem from Balkan? No, not Balkan, British. BMO2? Ah, crap. That was the one I never wrote up because I was worried about copyright concerns with the British MO. Ah! If you replace the gaps with 2, 4, 6, 8, 1, 2, 3, 4, then the sequences are Wythoff numbers. Okay. Okay. Hey though. The first one of evens is lane 3, minus 1 equals 2, then the first one of odds. Convergence, yeah. Alright, hang on, let me parse this. The first one of evens is length. I see. Okay, I get it. So the claim is that when I look up here, the fact that this is length 3 means that the first two terms are even, and then this one has... Or sorry. Starting from like... Here, yeah. So this is like 2, 2, 3, and this represents the parity thingies. Okay, so I agree if you break it into runs, then what we want is... Yeah. Oh no. The square root 2 run skips a number. Square root 2 run skips a number. I see, so the gaps, yeah, it's this, I see. So this 2, this 2, this 3. Okay. I think I see. Do you do competitive programming? Not particularly. I can like kind of talk to computers, not really. I'm pretty bad at it. So this 3 will do something, and then this 2. So okay, so like it's, I guess it's like these 2, 2, 3, 2, and something like that. Yes, I can kind of talk to computers. You are very good at talking to computers. Okay. Sure. Hello, computer. This exact Piatti sequence is on the... Hey, Hurdler, good to have you. We've been on this problem for a while. I was about to throw in the towel, and then someone had an idea. Okay, so we have these 2, 2, and 3, 2. This endpoint. Yeah, I like the combinatorial description. I'm trying to think if there's anything we can do with it. 10, 11, 12. Parse error. Yeah, we were looking at the continued fraction conversions earlier and couldn't figure out what to do with them. But admittedly, I was kind of like, I was hoping the claim might be true for like continued fractions with like, I don't know, like even the numerator and odd denominator that were less than a half or something like that. But oh, that didn't work. Then write the sum explicitly in terms of the sequence. Okay, let's do that. So we'll go ahead and actually write AK equals floor 2 plus root 2 k now. And it's enough to prove what? We want like help. So if I write that sequence, then like this guy is A1, right? This is A1, this is A2, A3. So okay, so we want like for even integers, A1 minus 1 plus A3 minus A2 plus A5 minus A4 to be at least the... Where do I cut it off? At some even index. Yeah. 2k minus 1 minus A, 2k minus 2. Minus 1, minus 1, minus 1. We want this thing to be at least A2 minus A1 minus 1 plus blah blah blah. Okay, so fine. Things happen. And this is the same as saying... So I kill off all the minus ones, and it's like A1 plus A3 plus divide out the 2. Okay, so that's what it comes out to, right? Minus 2. Cool. Alright, we want this to be true. With this definition. What's the song in the background? This is Still Lying There by Approaching Nirvana. Went from Geo to combo and now to... Okay, so... You know, now that I'm finally here, I'm wondering, like... Why did we take so long to get here? Did I just not think to look at runs? I think I just didn't think to look at runs at all. Even though the problem tells me they were in groups of 2 and 3. I guess I insisted on switching to root 2 plus 1, and that was kind of, like, self-harm. Maybe add A0. Um, I mean, I could add it, I guess, if you want. But I'm not terribly sure it's helpful, honestly. Well, whatever, we can keep it around. They should die to induct. Well, actually, you might be right. What happens if it's... Is it just true if I... So if I increase k plus 1, what's the change in the equation? It's like this thing should increase by a sub 2k plus 1, and this thing will increase by a sub 2k plus a sub 2k plus 2 all over 2. Does that look plausible? Oh, sorry, no. This is, yeah, actually, you might be right. Because it feels like the right hand side has two things which round down. So the right hand side heuristically just should be smaller. Really? Wait, okay. Someone tell me, is it actually true in general that like... Is this a true inequality? Okay, never mind. Okay, so never mind. So this inequality is definitely not true. Yeah, that's too much to hope for. Okay, that's fine. Back up. Okay, so we're not going to look at just one change. Jensen does not work here. The floor function is not convex. Or concave? Sorry, concave. Why is it square root 2 plus 2? No, concave up is horrible. Who says that? Oh my lord, no. No. Yeah, so we switched to 2 plus root 2, whose complement is... Why did we switch to? Whose complement is square root 2. And basically what's happening is that actually, this picture, this is root 2, this is root 2 plus 2, and the averages are the ones that are... The averages are the sequence you care about. Anyways, I think the upshot of doing this is that the original sequence, what you find is the original sequence looks like the length of the runs corresponds to the picture at the bottom. So I'll do it this way. If I fill in the picture, the sequence we actually care about is root 2 minus 1, which is not in the picture right now. But what happens is the parity is like 0, 0, 1, 1, 2, 2, 2. This, I'm just writing the sequence. So because of this line here, where the Yeah, the parity changes exactly when there's gaps in the root 2 sequence. So that's why we've switched to looking at the square root 2 sequence. So anyways, we've reduced to proving this inequality, which is like at least the close sum. Yeah, there's equality at the end of the 9 run. Yeah, which is not good news for us. Why is this inequality so strong? Well, yeah, I think square root 2, I think we're right, and like 2 plus root 2 or just square root 2 is the right thing. In fact, you know, actually, if I'm looking at this, the colored inequality here, it feels like we should just write like, we should take out the 2k part, right? So if I let bk just equal square root 2k, and I remove the 2's, the left hand side has like the sum from 1 through 2k minus 1, the other side has yeah, we can take out the 2 plus, I guess. And now it looks like this. I hope this is right. Yeah. So it would also be equivalent to prove it without the 2 plus root 2. That'll make things... Yeah, so this checks out. And so that's where we stand. We want to prove this inequality, and this is... what do we do here? No, you can't do it by induction. Or you can't do it by the obvious induction. Someone tried this earlier and we showed that it doesn't work. It's not true that if you increase k by 1, that delta is not negative. So you need something stronger. Yeah, the problem is there's too many there's equality cases that are later. So induction, but you use 2 basically and skip by 2 each time. Also can't work. The problem is that, like, so we have this thing, right, where we want to show this thing initially, like, k equals, let's just say k equals 1 is equality or something. I think it is. Is k equals 1 equality or k equals 0? It doesn't matter. Basically, there's a point at which k equals new computed that eventually this thing goes back to k equals 9. So no matter what you do, like, you know, even if you try to do it from k equals 7 and go like this, the delta is negative. So yeah, because of this, like, because it touches back down, there's no way you can get it by looking at just this change, because this change can be negative. Did someone put an ad break? Someone put a lot of ad breaks. Let me just remind myself there are k minus 1 terms here. EGMA 2015 problem in global. Which one is that? Yeah, actually, it would be equivalent to state this for fractional parts. But sum of fractional parts of I don't like it. We still need to use root 2 somehow. Like, it's just not going to be true for random irrational numbers. Yeah, I agree. The fractional part, it would flip the sign. But, I don't know, like, what am I going to do with it? Yeah. Root 2 looks too badly behaved. Yeah. Okay, so root 2 plus 1 was the one that had the really nice continued fraction, right? I'm not sure what property would I use of it though. I wonder if I could like try to use the same Python program and maybe we have a hope that if you have a rational number that's... Is that gonna work? Seems like a stretch. What's the hope? If I have a rational number that is close to the inequality is an equality if you take away the floors. For one. Like, it's actually an equality if you take away the floors. So this is a statement about numbers rounding in certain ways. The other thing I'm thinking is that we could maybe consider trying to look at the consecutive differences of the BI, and it would give us sort of the same... I wonder whether it would be the same thing with, like... Okay, can you get a fractal version of the problem where we transform the thing into a parity statement and then that you transform that parity statement into we transform a parity statement into the sum statement, and you transform the sum statement back into a parity statement or something like that. That seems really far-fetched. So anyways, this is the thing I've written here is that is that. Hang on. Okay. Sturmian word. Okay. So when is B3? So if I let B equals the root 2 minus 1, then each of these terms is either 0 or 1. And also B sub 1 is equal to 0. So when is B3 minus B2 equal to... Yeah, we're still on this. I told you this is going to take forever. People really... We feel a little better. So we're able to... What we did is... we looked at this root 2 minus 1 and we noticed it comes in blocks, and the blocks are described by the similar sequences for root 2 and root 2 plus 2. So like in this picture here. In that way, we're able to transform the desired inequality into something that doesn't involve a parity sum. It's just a straight sum of things. Now what I'm trying to do is transform the sum inequality back into a parity inequality, except with a smaller index, in the hope that I can try to do some very demented induction. Because I'm now down to here. So my question is, when is B3 equals to... When is this true? When is this true? This term here sucks. At this point, I should start writing what the sequence is. So... Okay, let me... I want a calculator. B7 minus B6. So this is the first few terms of the sequence are 1, 1, 0, 0, 0, 1. Does that match the sequence I have here? No. Maybe I grouped them the wrong way. 0, 0, 0, no. No, no, no. What sequence is this is like B3 minus B2, B5 minus B4, etc. And I'm trying to like very roughly I want to reduce the problem. I want to do an induction that's not induction by one. I want to like somehow group these terms in a way that it's like recursed on itself or something. Like this inequality we have, I want to show it's like, I don't know. Because when I write it this way, it looks like the binary sequence again, but because we've compressed it, it will allow us to do an induction. Like we can use the truth of the statement up to some small number. It's sort of like Cauchy induction, in which you show if a statement's true for n, you show it's true for 2n or something. Yeah, so it feels like it's a that the problem has a copy of itself inside it. But this sequence is not the right sequence. This one's off. It's basically I'm running into trouble because I have this b2k over 2 term here that isn't behaving. I don't think that will match. So maybe that means I'm pairing things the wrong way. The problem is false for most numbers. Like there's no way it's true for most numbers. So we've already used the square root 2 minus 1 once in order to change this sequence into these two things and relate it down to here. We probably, yeah. So we've actually used the exact number already. But I agree the sequence feels like it is fractal, and I want to find the right manipulation for it. I don't see it that way. Okay, so I want to not have this term here, because this term here is causing lots of problems. I should have a plus b0 here, really. Or, actually better, no, let me just, if I do b this way, then I make this b1 over 2. And now the number of terms on both sides is the same. So the question is, how can I pair them such that it like looks like it makes sense? So what if I do b1... I think in order for this to work, I need like a second order thing, right? Like, it's like sum of bi minus 2bi plus 1 plus bi plus 2. Found a good associated sequence. The Pell word. Okay. will that correspond to the thing we have here? I'm curious. I think I'm still writing Python too. The problem with this red thing is that this thing can be 1, 0 or -1. It seems to... Dang. X squared -2. Okay. If I... is there a way I can push this green line? Like, I want this green one to work. I'm not sure I can force it to. Okay. I think I better write this as like -1 to the I plus 1 times B sub I minus B sub I plus 1. And this thing will be the same sequence. Yeah. Okay, so I think that's how I want to write it. And this is now weird because this thing is either in 0 or 1. And this sequence is, the first terms of the sequence are 0, 1, 0, 1. Wait, so this is the same sequence, right? This is the sequence we were looking at earlier. So it's written a little differently now because instead of -1 and +1, we have like 0 and 1. But it's twisted with this, it's like, this thing is strange. So is this the same thing? Are these equivalent? Like, I feel like this is... I want to say this is exactly the same, but I'm not 100% sure. Yeah, this is the same word that Andrew found, except with... Wait, let me check. 1, 1, 2, 2, 3, 3, 3. It might not be quite the same one actually. I'm just confused at this point. I'm confused why this -1 to the I plus 1 showed up during this calculation. Actually, so I think this is 2, 2, 3, 2, 3, 2. I think it's the same word. Why is B1? Well, B1 equals 0. Yeah, I wanted to normalize them so that some of the coefficients on both sides are the same. So when I did the adjustment, I forced it such that B sub 1 was equal to 0. So this is the sequence bi minus bi plus 1 minus bi. Whereas the original thing we're looking at, wow, okay, there's so many related sequences with different conventions that I'm having a hard time keeping track of them. Sum of index times coefficient equal. Well, I'm doing this, so. Yeah. So, this sequence that we have here is, I don't know what I call this. Well, we'll call this root 2 minus 1. Okay, let me verify to myself that this does what I want. Oh, my Apple Pencil's running out of battery again. This always happens. Print K and zero, zero. Green 0011. Yeah, so I think I'm pretty sure these are like the same sequence in some sense. Like what happens is in the BI sequence, I think the super long one was more like 3 hours. It wasn't quite 5. But basically, so let's recap. And this is the thing, I think Eknarwala has given us actually the exact word as well. And it's starting to come together. So we have the sequence 001122, these parodies. We found that the places where it changed sign corresponded to the sequence of like root 2's here. So like this root 2 sequence. Consequently, the original inequality boils down to this statement for like a sub k equals 2 plus root 2k, because by Beatty's theorem, the gaps are here. Then we subtracted 3, and we got this green thing, and this green thing rearranges like this. So it's similar, except now there's a -1 twist here. And this is like a sequence that's either 0 or 1. And what we found is that this BI sequence, if this is true, I assume it's like not very hard to prove. Also, why is the sign flipped? No, the sign's fine. For I equals 1. Hang on. Did I flip a sign? I flipped a sign, didn't I? Yeah, it should be bi plus 1 minus bi. Oops. Now we see that this red sequence, well, our claim is that this red sequence lines up with the green sequence. Wait, my sign is right? No, you want like... Hang on, what did I do? Okay. B sub 1 should be... Oh, okay, I see what I did. Let's just flip them twice. It's very annoying if the yeah, I want this to be in 0, 1, and this should be minus 1 to the I. That's fine. Yeah, so it's the red thing now turns out to be the same as the green sequence, I think, where it's 1 at the places where the green sequence changes. So when this changes mod 2 is exactly when this thing yeah, that should be pretty clear. So what's happening is like when I look at blocks, then whatever. Okay, so now I would like to bring this back into here somehow. So what's going on? So this is no change plus... The problem is this minus 1 to the I is confusing the heck out of me. But I would like to use the... reduce this to this being... So if these partial sums are all non-negative, I think so, yeah. So the in the B minus B sequence, the runs are corresponding here. The runs always have length 2 or 3, so yeah. I wonder if I just pair them into blocks or something. Let's make this block. So this is like plus 0 minus or something. And this is like plus. And this is plus, minus. So if I throw out the zeros, plus. Yeah, I think it's the same sequence. Because the zeros, it's always 01 or 00 and then 1010. I think this is a complete fractaling. If we've got it, I think this will work in some duration. I don't know how this happened, honestly, but I think this is like this purple. I think these purple things like plus and 0 minus. It should be that, right? I think. I'm a little confused as well right now because. No, hang on. I'm stupid. I claimed the second collapsing somehow, and I didn't justify it. I'm somehow pulling them back in, like the... I agree we're very close. I think we're almost there. Let me think this through a little bit. Maybe my purple signs on the bottom are wrong. I think I'm trying to redo the problem twice, and I only need to redo the problem once. What do I want to claim? I want to claim that at the end of each red block, the total delta is equal to twice the total delta on the bottom, or half. Sorry, yeah. So here's the claim, I think. I'm gonna write these numbers in blue. Yeah. Ah, crap. The purple, for some reason the purple doesn't erase. Frick. Right, so in blue, let me write so this is +1, +2, +2, -1, 0, +1, for example, on the top. On the bottom, this is 1, 2, 1, 0, 1. What the heck? No. No. What the frick is going on? No, so it does have, I think. Okay. It goes from 2 to 1, not 0 to 1. Wait, what? 1, 2, 2, 1, 0, 1. Okay. And then this is like 1, 2, 1, 0. Right? It goes from 2 to 1. not 2 to minus 1. I'm just a little confused. So 1, 2, 3, 2, 1, 2, 3, 4. I need to group the 3 block as 3. Oh, that makes sense. Yeah, actually, that makes a lot of sense. Yeah, I mean, so this is the thing Eknerwala was pointing at earlier. It's like, it should do this. But I feel like, how do you prove this, though? Along a run of 2 blocks. There are on each side. Apparently the 3's determine how long a run of 2 blocks there are on each side. It's still in the same sequence. How do I show it? Two with a 2, 3. Yeah, it's the sequence that I can roll on is this one. It's like, and I think this, the thing we have is basically a variant of this. So yeah, either that or exactly the same, depending on how you normalize it. The thing I'm trying to figure out is like, how do I explicitly get the, like, I feel like I'm in a situation where I know the things are true. Like, I know that the sequences are quote unquote the same for whatever quote unquote same means. But I'm not able to, like, I want to explicitly get like the BI statement. I want the green thing to tell me something about the red thing. Like the bottom, I want the fact that this thing is non-negative to tell me something about the thing above it being non-negative, and I don't see how to force a second connection or something. But I feel like I should just be able to do it or something. I don't see where I'm stumbling. What am I missing? let's just group it into chunks. I think it should be true that the end of each block is non-negative. Like this 0 is corresponds to like this thing here. Like it's like plus plus minus minus. But I was hoping that this thing would like line up in a more one-to-one way, because otherwise I don't. Yeah, join the struggle bus. It's definitely the same sequence. But, like, if I can prove this, then I probably could have solved the original problem using it, I think, or something like that. So... So what am I missing? What exactly? What do we want? I want to prove the red inequality is the TLDR, and I can use the green inequality for granted by induction hypothesis. Or not green. The green. I can basically I want to like use the green thing to prove the red thing. Like the fact that this green thing goes like up up, down down, then up 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 up, down down, and I want to use this to like say something about the red sequence, and I am really struggling. The strings of length 3 happen on integers of the form. The strings of length 3 happen on integers of the form 4 root 2 plus 1 I. I see. Okay. The lengths of the strings follow the same. Do you mean like root 2 plus 2? Not root 2 plus 1? No. Wait, what? Subtracting I. Or I guess I'm a little confused because like the first few integers of the form floor root 2 plus 1 times I are like 3 and 6. But these flips happen at like not this one happens at index 5, this one happens at index 3. I guess I'm not totally sure what you're subtracting from what. Oh. Okay. I see. You're not talking about the index. You're talking about. Oh, okay, got it. So this is the. This is with the move down bi. Fine. Do I think I can write this up? I feel like this write-up is going to be so confusing because it's like doing the same thing in. Oh, this is going to be a fun write-up. Alright. Alright, let's give it a shot. It sounds like we have all the ingredients. I am still kind of confused, but we'll work it out. So it turns out we didn't use continued fractions. I'm glad we got it though. I didn't think it was going to end. Okay. Let's find out if we have everything. Yeah, I was about to, I was like, this is not working out. Alright, so for concreteness, we illustrate several terms. I think I'm going to have to look at this table so many times. I may have leaked one of my, oh no. Oh, you shouldn't have said that. Okay, so the sequences we're looking at are like root 2 plus 2, root 2 itself, and then root 2 minus 1. Biati to advanced. That's fair. One, two, three, four, five, six. 1, 2, 3, 4, 10. What did we agree the first few turns of the sequence were? Is this a little... Putnam problem difficulty varies quite a bit. I will say this feels like... I feel like this is on the hard end for a B6. I would not say this is like the hardest B6. Okay, 14... Okay, so we'll go up to 13. I think that's... Oh crap. Actually, this is really hard to typeset. 17. Okay, that should be enough terms. And then on the bottom, we will write square root n minus 1, 0, 0, 1, 1, 2, 2, 2, 3, 3, 4, 4, 4. So these are the these are the different pictures we're going to be playing with throughout the problem. And I have a compiler, great. Extra alignment tab. Have more. Now let me cut out 18. Okay, so claim, so by Biati's theorem. Okay, well you can watch the write-up while so I'll be honest, I'm not sure we have a solution. I think we do, but I am confused as heck. So the sequence is root 2n and root 2 are disjoint and form a partition of the positive integers. On the other hand, in the bottom sequence, the consecutive runs should all have length either 2 or 3. So, well, let's give these sequences names. AN equals this, BN equals this, CN oh frick! I did fractional parts. No. Oh, this is annoying. Record macro. See change left L floor, right R floor, Q A. I love him. Oh frick! It's left L floor, not R floor. That looks terrible. Showing the first 17 terms. Grouping into those blocks in the bottom, it is enough to show that. So we want the sum of Okay, so when we do the block statement, it's like a1 minus so we want a1 minus a0 plus a3 minus a2 minus 1 plus blah blah blah, and we want up to a2k minus 1 minus a2k minus 2 minus 1. We want this to be greater than or equal to a2 minus a1 minus 1 plus a4 minus a3 minus 1 plus so on plus a2k minus a2k minus 1 minus 1. That should be displayed actually in 2 lines. It's too long to fit on a single line. Okay, so do we agree we wanted to use I called it B in the thing, but so using the fact that AK equals 2K plus CK and then rearranging appropriately. Oh, I'll just say we can replace every AK with CK above. Then rearranging gives the desired is equivalent to the sum from I equals 1 to 2K minus 1 of so. This is 0 or 1. Okay, fine. Okay, and so we're kind of looking at the CI plus 1 minus CI. Thank you, 579 for the follow. So I have to write another row here for CN plus 1 minus CN. So it's like 0, 1, 0, 1, 0, 0, 1, 0, 1. Sorry, I missed the in-between. When you're done, can you briefly explain what's being done? So the problem statement is, I mean, it's up here, it's this thingy. So it's the Putnam B6. And very roughly, our solution revolves around making like this very large table and crossing our fingers. I am not totally sure what's going on myself, but I will post it when I'm done if it indeed turns out to work. I think it should work. Okay, so now we need to prove that this thing is, shoot, I forgot the -1 to the I. Yeah, so when I draw the table like this, it's a little more clear what's going on. What am I trying to push? What are we supposed to do after this? we have like this thing. How did we show as fractal? I want this the indexing of the runs corresponds to the original sequence. 1. So in the notation that's written here, what's the correspondence I want? Okay, a-nth block. It's not a-nth though, right? Like, because this appears as the third block and this appears as the fifth block, right? Did we make a mistake? Root 2 plus 1. Okay. But then that's like second and fifth. Or, no, not second and fifth. Second and fourth? And first? Yeah, second and fourth. This matches. Oh, are you counting this as second and this as fourth? Okay, that's fair. So the claim is that let's see. Consider the blocks of correspond. The blocks of lane 3, of course, is exactly corresponding to the elements of the set. Okay, so I have to add like yet another one. Do I ever use root 2 and I feel like I don't. Whatever. No, I kind of do. I use it for the BID. Okay, and the proof is just to look at consider AI minus I and BI minus I. Two, 4, 7. Yeah. So what do I do with these two sequences? I'm a little lost. So if I subtract I from each of these, this is like, I get this thing. And then there's a sequence. So these two are complementary. And okay. Like Yeah, so I agree. Root 2 plus 1. Which sequence is A and D and complementary to? It's like... Thank you, Lucario61 for the follow. Two plus 4 is that 4 apparently. Why? Yeah, I guess I just don't see which sequence is complement to DN. Okay, so I'm not just missing something. Well, I agree, it's true. Crap, that was important. I needed that though. Oh no. We're a little confused. Like I think we have the right picture, but I can't see how the details work out. Okay, I'm gonna comment out this row because I don't think this row really fits in the picture. Walking through BN, an adjacent pair means there will be a 2 later down. The line in the gap means there are 3 down the line. I mean, all these things are true. I just can't prove them. Not hard, it's just Biati. Okay, what's the Beati counterpart for root 2 plus 1? It's like... root 2 over 2? That doesn't make sense. Yeah, 1 plus root 2 all over 2. I think we don't really want to play with that. God, yeah. What a day. If one is in... Okay, if one is in Vn and 2 is in Vn, then 1 plus 2 and 2 plus 4... Wait, really? Like 9 is not in... Wait, 1 plus 2 is not in AN. 2 is in... Wait, what? 1 is in BN and 2 is in BN. 1 plus 2... Or, no. 1 plus 2 equals 3. Right, but if I do... Like, if I look at 4 and 5, right? Like, 4 and 5 are here. That sum is 9. Am I not understanding correctly? Four and 5 correspond to 10 and 13. Now I'm really confused. What are we... Okay. If one is in BNT... Hi, finally I find a mathematician. I don't know if I qualify as a mathematician, but hello, welcome to the stream. Okay, wait. No, why is that here? The heck? Do you know abstract algebra, bro? I guess, kind of. B sub n plus 2 sub n. Okay, I see what you're trying to get at. So you're saying that from this thing, can we do one later? Oh, do you have an abstract algebra problem or something? Yeah. You can just post it in the chat, and if I can quickly see how to do it, I'll say so. Or possibly someone else will grab it. Um, uh, okay, but okay, I see what you're trying to do. So if bn is here, right, +2, okay. Um, okay, so if I have a length of run 2, then it will generate a run 2 thing later. Got it. Okay. Okay, so scrap claim. So the claim is that oh, this is tricky. Yeah, basically, if I know something, I can read some term in the future. I don't know how it will, exactly what future term that is. Freaking. Okay, so, right, so for each term, consider, so 7, if there's a 7, 8, 9, then that will give me, which one is 7, 8, 9? This is a B5, so it's like the 17, and then the, 17, 20, yeah, 2, 2, 3. Okay, so you are correct. This will correctly give the fractal thing. So how do I formalize this? 2, 2, 3. So claim the, I'm not sure what the claim is actually, but I'll try to write the proof first. So imagine reading bi from left to right. If bi plus 1, bi plus 2 are adjacent, i.e. So bi plus 1. Okay, so then AI plus 1 is equal to AI plus 2 plus, hang on, yeah, plus 2. AI plus 2 equals AI plus 1 plus 2. Sorry, this is plus 3. So this will give 2 blocks. So this will, in the future, ahead, this gives 2 blocks of length 2. In the future. So for NSA Hacker, I'm a little confused now, because you sent me a wiki on abstract algebra, which is fine. So I'm looking through this, and it explains what abstract algebra is. And then you gave me a question about two linear equations, which like doesn't have anything to do with the wiki page you sent. So, yeah, I'm not sure exactly what the question is. If the question is just how do you do this, how do you do the first brilliant question, add twice the second equation to the first one. Alright, Jason. If bi plus 1 minus bi equals 2. Okay, so that'll do fine. So that means the adjacencies here, whether it's adjacent or not, will predict whether what the blocks look like in the future. So the upshot is that the size of the blocks corresponds to the something. What does it correspond to? If I chunk these as 2, 2, 3, 2, 3, then unable to. Yo, sorry. Yeah. This is a little Yeah. I'm trying to figure out exactly how I want to formulate the claim. I think the claim I want to say is so 2, 2, 3, 2, 3. I want to correspond to how do I phrase the fractalness? So what we're pointing out is that if I have, for example, 4 and 5 here, then it will give a block of to something later on. It's like 2, 3, 2, 3, 2, 2. What was the claim we're trying to make? So this is plus, plus, this is this. Like I want this block to be this digit. Just plus, plus, minus, minus. Okay, I got it. If we read Cn from left to right, the indices for which Cn changes value correspond to the blocks, the consecutive length 3 in Ci plus 1 n plus 1 minus Cn. More explicitly, the ith. So the ith block of Ci plus 1 minus Ci has length 3 if and only if Ci does not equal Ci minus 1. Since I'm a mathematician, I want to go ahead and try to do a 1 index here, I think. This is C1, so first, second, yeah, CI plus 1. Thank you, NSI Hacker, for the follow. I hope that my brilliant help was helpful. If and only if CI plus 1 does not equal CI. Yeah, this is C2, this is C3. Well, I really should give this a different name. Let's call this DN. This is a different sequence. Yeah, okay, and this is, yeah. Alright, cool. Wait, I think this is now a proof of the recursion thingy. And now, in fact, I claim this is true for any positive integer k. So in fact, I claim that this thing is true for any integer L. Yeah, we found a very difficult way to describe the thing that was happening. So now that we have this claim, I believe we should be okay. Okay, okay, wait, so if the -1 to the di is yeah, exactly. So I under soldier combo algorithm, I guess. Like basically what happens is, like, when you look at the 7, 8, for example, this thing gives, oh geez, they're really big. 6. Hang on. I'm never gonna get this indexing right. Let's say 4 and 5. These numbers are smaller. Like this is 10 and this 13. So the fact that these are adjacent means that later on you have a gap of length 2. Yeah. Okay, cool. So now we should be able to finish it off, because hence, if we take the first m blocks of di, each individual block sums so each individual block sums to ±1, because only the last bit is 1. Moreover, the sign is +1 if and first. So we change from n to k to l. What's next? M. The sign of the ith block is +1 if and only if ci equals ci is even. Yeah. Right, because this is because the 2 2 3 2 3, yeah, okay, great. Thus, because we have reduced, thus through the long convoluted chain of reductions n to k to l to m, we have found a smaller version of the original. Have the same inequality with a smaller input value. Since the inequality is clearly true for n equals 1, for a base case n equals 1, the proof is completed since n greater than 2k greater than l. I'm not being very careful at this point. The proof by strong induction. Alright! 29 minus 4 for base cases n less than let's just say n less than 10 to be safe. I don't care enough to work out what the smaller. We did it! And it's now too late at night to play video games. God. Yeah, I agree. Oh my lord. What a problem. Oh man. So glad I found this channel. Great content. Thanks, glad you enjoyed it. I think this channel is funny because like I have no idea what I'm doing, as you can tell. Like we solve the problems live. So it's not like other streams. Like I think there's a lot of YouTube channels where you see the person just kind of presents solutions. The solutions are really clean and they do a good job of explaining it. And this is exactly what doesn't happen on this stream. It's like, instead it's me like, you know, crashing into walls repeatedly. And we do it live! Oh my god. I kind of want to try 2006 because it looks easy, actually. I was thinking a little bit about it during the break. And I think I know, like, basically what I'm supposed to do, but I'm afraid it might take too long if I try to do it now. Oh lord, what a problem. Fractal root 2. I'm actually glad I didn't think I was gonna get it. Like, I was just like, I have no footholds, and then it ended up being the Beati and the observation that we could put things into blocks that started things off, because I don't think I would have gotten that far without that. So thanks, Duke. Can you also share the final paper? Yeah, so I'm gonna, actually I can just post now. Give me a moment to save everything to the database. What do I call this? Rigid? Parity? I'm trying to decide what I want to tag it in the database. Okay, whatever. Alright, so now we're going to do the very Freaking, I always type that URL and then realize that that's not the correct URL. Putnam 2020 B6. Okay. Ta-da! Yeah, so I guess I'm just doing this now. But also, just for the record, if you look on... Oh my god. No! Wait, what? It compiles on... Oh my god. No! What's the error? Oh, I commented out a line, that's why. I need to be better about the new lines. Yeah, it took the entire time limit of the Putnam. But anyways, if you look on videos.html, so you go on my website and look under YouTube plus Twitch, I actually put up all the write-ups that I do onto a page here. I update this like maybe once a month. So it will eventually go up here as well. But you can find like all of them. It's like, not all of them, there's some that I don't write up because I'm too lazy to. But it goes back quite a, yeah, there's a lot. Many write-ups. Jesus. Okay, that concludes this wonderful B6. Thank you all for tuning in. And yeah, we're done. Okay, do you guys think we can do the 2006? Good work, boys. Yeah, 3 hours later we finally got it. Is there? No, I... See, so here's a problem. I have to wake up early tomorrow morning to teach office hours, so I can't stay up very late. Alright. You guys better help me out. Oh my god. Alright, alright. Thank you, General Lead, for the follow. Wait, is the stream lag that high? I feel like this problem's probably easy, so let's just run it over, alright? Please no. It's okay, the problem looks easy. This problem looks easy. Also, how far behind is my stream? Is there a way I can fix the stream delay? Alright, well. Alright. Alright, everyone, welcome back to late night IMO shortlist. We have an actual IMO shortlist problem this time. So this time we have 2006, and this is the statement. So basically my idea is that I was thinking about this a little bit while we were doing the other problem. Roughly, I want to say like induct, by which I mean, can you say when you see it? Yeah, I see. Okay, yeah. So let's take like just 3 random odd squares, right? Then n minus 1 of like n minus something like less than or equal to 34 will be divisible by 4. Or something like this. But basically, like, you can make stuff, if n is big, you can make it divisible by 4, and you want to sort of repeat, maybe. So the problem is, like, I don't know what the threshold should be. I mean, right now, as written, this won't work, like, as... This can't work as written, because, like, there's no threshold. If I set a threshold m, then, like, each time I do the induction, the threshold gets higher. But I think the idea should be along these lines. So let's see what I can do. Oh, that's a good idea. Yeah. So the other idea that's good is if there's a fairly large perfect square. So let's say like if x squared is between n and n halves, then subtract it and, well, also induct down. But the problem that you also get is that basically the finitely many thing is an issue. Like, you have finitely many counterexamples, so you want to not like hit one of the counterexamples when you descend like this. Yeah, but both induction ideas sort of run into this problem where we're a little worried about On the other hand, so there's a theorem that says I mean, there's a theorem that says that any integer can be written as 4 squares. Any integer can be written as the sum of 4 squares, but unfortunately not necessarily distinct. So all I need to do is like the other idea does cover every integer. Does it? If I have like n minus x squared, like what if n minus x squared is not is one of the counterexamples or something, right? On the other hand, if I found like an interval for which like there's not too many bad numbers, it would also kind of just be okay. How big do I think the threshold is? Yeah, like if 51, if every number bigger than 50 works, then what I could, in principle, I guess what I could do is I could manually inspect like 50 to like 100-ish. Oh no. Do I want to go this route? Here you go, like... Oh, Jesus. How big do I think the counterexample is? 7 mod 8 numbers are the worst ones. Those are the ones for which you need odd squares to... You need a 4, you need a like 4 and then 1, 1, 1. So... Actually, that's not bad. That's like 1, 9, 25, 39. Yeah, so I wonder if you can just find an interval for which you can go from like m to 2, like if I can paint an interval from x to 2x for some fixed x, I can get all the numbers in such an interval, then this idea will kind of work, right? As long as you can find a square such that n minus x squared is greater than 23. If we think 23 is the biggest counterexample, yeah, that's why I fill in 24 or something. Yeah, as long as this number is at least 24, and also x squared is greater than n halves or something like that. Oh shoot, 24 also. 25. So if I can promise that there's a square that does this, then I'm okay. And for most large n, this should be true. What's the exact condition I need on n in order to promise that such a square exists? So on the one hand, I need n to be at least 50. On the other hand, if n is at least 50, then... Do I run into weird integers? Oh no. 27. Yikes. It gets worse and worse. Please. So anyway, I think the correct choice is that x should be... okay, let's call the threshold m. And then x is like x is the floor of square root n minus the threshold n. And I need this thing to be bigger than n halves always. So I can write this as root n minus m minus 1 squared is bigger than n over 2. Expand the left hand side, it's like n minus n minus 2 root. Okay, and if I rearrange this is n over 2 plus m yeah, so I don't need n much bigger than capital M. I just need n bigger than like 2m is not quite enough, but like 2m plus like square root m-ish should do it. Okay, so what do we think the threshold is? Like, if the threshold's not too big, we can just run it over, right? Like, 31 we think doesn't work. Do we think anything bigger than 31 works? Can you get 32 actually? How do you get 32? All right. Okay, let's do 36. Okay, 25 plus 43 doesn't work. What if we just DP table, get this out of the way? I think that sounds reasonable. I also wonder if like, so it sounds like all the problem is all the 3 mod 4 numbers. The 3 mod 4 numbers are causing problems. So like if I just optimize a little bit. Yeah, so rather than trying to prove that all the can I use the I think the algorithm is pretty ad hoc. I think the algorithm is called try for small numbers and see what happens. $43 doesn't work. Okay. How do you do 44? $47 also doesn't work. 7 Monday numbers are really bad. Okay. I'm not sure we can do this just by brute force. Okay. Here's a different idea. What if I try to get it down to a 1 mod 4 number? Because we're promised that a 1 mod 4 number is always the sum of 2 squares. No, sorry, that's false. God, that. 1 mod 4 numbers in some interval with sum of 2 squares. Oh god, this is so bad. Yeah, I had the same thought. So you try to pick a big square so that it's 1 mod 4, and you try to get all the 1 mod 4 numbers in a certain interval. That seems like it's quite feasible, because the only ones that don't work are the ones that have weird 3 mod 4 factors, and there aren't too many of those. So I'm just trying to think how big of a threshold we're going to need in order for that to work, though. That's because in worst case, n is 3 mod 4, so you need to do this like subtraction operation 3 times. Or something like that. I wonder if the parity idea would have been better. Because that's a little more controlled. It's like you only subtract off a little bit. But the problem is the magnitude decreases a lot more rapidly. No, I think the problem is definitely. I'm not surprised at all this is true. Like, Lagrange's theorem tells you that a number is just like the sum of 4 squares. And so the only thing that you're worried about is, oh, maybe you can't, some of the squares coincide. But that's not that likely, right? Casework. I had the thought, but I don't know if there's a good way to deal with it. I mean, what are you gonna do with 2a squared plus b squared plus c squared, I guess? Like, I guess you can hope that... Yeah, I had the same thought. I want to show all 1 math far are eventually good. Yeah, I think that's the best approach. Okay, so for 1 mod 4 things, where do I start? And 3x squared plus 4. Okay, someone tell me how many base cases I need? So the only I claim 1 mod 4 numbers. Are eventually okay. So the only ones I have to check are... It'll never be 2x squared. So I'm only worried about the numbers that have that are the product of 3 mod 4, like some product of 3 mod 4 primes. So 3, like 21 is like one of the first ones. I think 21 actually is fine. This is 5 squared plus 2 squared plus 1 squared. Actually, hang on. What's this 3 squared theorem say? The 33 is 5, 4, 3. Not a cap of 7, okay. 33 is actually bad, right? Can you write this as a sum of distinct squares? Alright, so that's bad. $51 is okay, 55. Aren't those numbers 3 mod 4? If 51 is 3 mod 4, right? I don't really care about it. $59 is bad. Oh, that's not good news. No, 59 is also 3 mod 4. Guys, I'm looking at one more font numbers. Okay. You know, this will actually be faster if I use my tablet. Because I need more space. Okay, so I'm gonna write all the 1 mod 4 numbers. It's actually easier. I don't think too hard about this. And how big of an interval do I want? I want like okay, well, here's like the first gazillion. 65 is bad. No, it's not. It's 7 squared plus 4 squared. So which ones? The only ones I have to worry about are the ones that have 3 mod 4 factors in them. So 33 is potentially worrisome. 45 I don't care about. That one. So what are like the 3 mod 4 primes? 3, 7, 11, 19. So I'm looking at the numbers that are like products of these things. So 33, 77, 57, 130, yeah. 209. I guess 105 technically. Okay, so which ones of these can't I write? So 33 is actually not possible. So 57 is that possible? That one's fine. 77 is probably alright, right? 8 squared plus 3 squared plus 2 squared. And 105 is 10 squared plus 2 squared plus 1 squared. So this is much more efficient. Right. Yeah, so all of these should be okay. Actually, I need to check. Hang on, there's more primes. 8 squared plus 2 squared plus 1 squared. 87. Oh, sorry, that's not it. 93. I need to check 93. 64, 25. What was the checking optimization? Yeah. So the checking optimization is that if a number is a product of 1 mod 4 primes, then it's guaranteed to be a sum of 2 squares. Also, if it's divisible by like 9, for example, you just factor out the 9. So the ones you have to check are ones where there is a 3 mod 4 prime factor that appears with odd multiplicity. That doesn't happen that often, actually. And, you know, it's these circle numbers here. Okay, so I think this is a complete check that 3 mod 4 numbers. How many Border cases can I generate? I'll just keep generating a few more. 113. I'm not really able to check whether these are prime, but it doesn't matter. I just need to check for bad prime factors. 133 and 3 and 43. I need to check these two. 133 is like... Yeah, these are all pretty big numbers. You can just do 100. Oh, you can add 100. That's a really good point. Because I didn't use 100 for anything up to... Okay, so we get everything up to 197. So everything from 37 to 197 is good. So all 1 mod 4 from 37 to 197 are okay. And actually, if I can do that, then I can probably take the next one, right? Like I can add... Yeah, and use squares. Not only are they good, they use squares at most 100. Everything here is at most 100. So what that means is I can now add like 169 or something. That's actually too big. So, but now, if I add 121... Wait, actually, why didn't we do this before? Hang on, wait, why didn't we do this before? This is just better. Right? Like you have a set and then add 121. So everything from 158 to 279. Okay, and uses at most 121. Yeah. Yeah, and yeah, so you just kind of keep pushing like this. So that will give us every 1 mod 4 number. Yeah, you're actually, yeah, so this is correct. It's like a constructive approach is better than a destructive one. Okay, so you get all the 1 mod 4 numbers, and actually, if you just vary this like very slightly, it'll also work. So, you know, what happens is the growth rate of this is a lot faster than the growth rate of the squares, right? So plus 144, so this is like 302 to 423, and so eventually, yeah, you just kind of get something that's a lot stronger. Plus 169, 592. Yeah, so this is like 471 to 592. Yeah, so now we should be okay. Because, actually, first of all, I misadded. This goes to 318, right? And then 462, and then 631. Yeah, and now we're fine because once you get this, yeah, this is clean. Hang on, wait, why is there a gap here? Is there actually a gap? 302, 460. No, are you? Is like 464 just not achieved anywhere? Hey, are you serious? No, that's a joke, right? Oh, god damn it. Oh, sorry. I'm just being stupid. I don't care about the lower bound. I only care about the upper bound. Yeah. So all the numbers up to... Yeah, no, this one. Also, okay, yeah, I should be... Hang on, I can't use 121, because that will break my 1 mod 4. Okay, wait, I have to be a little careful. Alright, let me try to be... So, we did this thing where we added 100, we got everything from 37 to 197. Alright, let me do this correctly. So then... So we can, from 37 to 197, we got all the 1 mod 4 numbers using squares that were only up to like 100. Then if I add 144, you can get everything from 37 to 341 with 1 mod 4 squares that are all at most 144. And then the next one is 196. And again, you can get 537. Okay, yeah, I should be careful. So then you do 12 squared, then you add 14 squared. Yeah, and then, okay, so eventually you can get all the 1 mod 4 numbers. And finally, to do the reduction, you pick like... Yeah, right. So because when I do this, I never use 11 squared, 13 squared, or 15 squared. So now I can use that for the general situation, and then it'll work. Okay. Okay, great. Okay, see? Told you it was easy. It actually took longer than I wanted it to. I was hoping it would die in 10 minutes, and it took us for like 20. Alright. So let me do the write-up now, because so I don't have to think about it later. And then we can call it a day. This write-up should be quick. Fun problem. What does stog mean? Is stog just strong? Computational fortitude. The Ibero-American 2020. What the heck? You're correct. I don't know how that happened. Because I remember typing the full solution. Okay, thanks for letting me know. I have to add that to my to-do list. Finish Ibero. Okay, anyways. Okay, so... Okay, so we prove the following claims. We start with the following base cases. Base case, every 1 mod 4 number can be greater than at least 37 is good. more strongly. Think perfect squares. Actually, let me not do that. At least 37 is good. So we only need to check numbers which have a 3 mod 4 prime factor with odd multiplicity by Christmas theorem. This is easy because 57 is equal to 6 squared plus 4 squared plus 2 squared plus 1 squared. Plus 69 is 8 squared plus 2 squared plus 1 squared. Yeah, and today has been a long day. So, okay. Claim now, then the following corollaries take place. Every 1 mod 4 number from 37 to 97 can be written with squares at most 81. By adding 100, oh, hang on. From 37 to 133. There's more cases I need. So 105 is 10 squared plus 2 squared plus 1 squared. 109 is 10 squared plus... Sorry, 129 is 10 squared plus 2 squared. And 133 is 8 squared plus 7 squared plus 4 squared plus 2 squared. The other claim. Every 1 mod 4 number between 37 and 197 can be written with squares at most 100. We never use a... Okay, then by adding 144, every 1 mod 4 number from 37 to 331, then by adding 196 squares in the set 0 squared. $527, right? So in this way, every sufficiently large 1 mod 4 number may be written as sum of distinct squares. Yeah, the self-referential basics was quite something. So the sum of distinct squares from the set 1 squared, 2 squared. Squared. Good. Okay. We did it. Alright. Alright, so let's see how this looks. Where's the PDF viewer? Yep. Okay. Theory, casework, size? No. It's 128. Well, I'm glad that we... Your claim is wrong, Evan. Which one? Some things greater than 121 require 121. Things between... Oh, freak! You're correct. Oh, no, alright. You're right. Okay, so this has to be 11 squared. Okay, 3. Whatever. Yeah, the fair amount, yeah, 11 squared shows up. It's fine. I'm pretty sure 11 squared probably is actually... Can't just pick... Yeah, sorry, so this should be 13, 15, 17. It's how you get a 6. If I'm grading and I notice this, you always get a 6. Don't make mistakes. I feel so hypocritical a lot of time when I tell students not to make mistakes because I make mistakes all the time, but I'm pretty sure I'm still supposed to say that because I'm the teacher. Yeah, I'm actually like not very careful myself, but don't be like me. Yeah, it's kind of a funny problem. Alright, well thanks everyone who stuck out the whole time. I guess this makes up for the last 2 streams where I cut off the math pretty early because I was tired. We got B6, N6, and that Geo, which is long day. Still in residue holds. Oh wait, was it Geo problem 7? Oh, I didn't check. Alright. The J06. Yeah, today is the day of the sixes. There you go. Oh my freaking. Ah, stop! I was trying to load the stream manager and I ended up on the Twitch homepage and it started auto-playing. Alright, see y'all. Hope that was entertaining, maybe.